Hello, I think we're live now. How is everyone doing? It's good to be on another stream in this sort of week where I'm trying to stream every day just to see what happens to the YouTube channel, whether or not we get some more traction on it. That's basically what I'm trying to do. And yeah, in today's stream, we're actually going to be creating or beginning to create an audio visualizer in C++. And again, we're going to be working remotely from the Raspberry Pi on my machine. So I've got my Raspberry Pi on the other room there running an Ubuntu server, which is basically running as my sort of build server. And we're going to basically just connect my Visual Studio code into the Raspberry Pi and basically just code from there, really. So the aim of today, as you can probably tell from the YouTube description and the title of the stream, is to begin the creation of an audio visualizer. And if you don't know what an audio visualizer is, it's basically sort of like Windows in the early 2000s. So, you know, whatever program that you may have had back in the day, where you play the music and the music will show you some nice visuals. That's what we're going to be trying to do. In the first instance, we're going to aim. Audio visualize, that's what I meant. We're going to aim to just basically display the waves here, so the frequencies and how loud each frequency is, which kind of will look, I guess, something like this. But maybe we can develop it in such a way that you can make more complex visualizations with, I don't know, different shaders or whatnot. But if we aim to just do a very basic visualizer at the start, where we analyze each sort of like frame of the audio, and we kind of get the frequencies and display that every 10 milliseconds. I mean, I'm happy with that. That's a fairly good result. Obviously in today's stream, we're not going to be achieving all of that. I'll be very happy if we can just sort of display a triangle on the screen. In other words, I will be trying to set up the build system with CMake, and I will try to set up my dependencies as well with Conan, and we'll make heavy use of perhaps OpenGL and GLES and GLFW to create our window and display graphics. And in future streams, we can integrate more things to our little program, such as maybe we have port audio to actually not display, but to output the audio. And we have things like wave parsers, where we can sort of import audio files and MP3 wave parsers that will be sort of necessary for reading these audio files. So we can do some research as to what libraries we can use for those. Obviously, I'm not gonna be writing the parsers for the audio, and I'm probably not going to be writing the Fourier transform part of it as well, because once you have the audio in memory, you're going to basically get a chunk of the audio, and you can basically see what frequencies are in that chunk. And this is done with the discrete Fourier transform. So if you know FFTW, that's the fast Fourier transform algorithm. We could try and code it ourselves, but there's no way it's going to be as fast as just getting a library that's already done by someone out there and basically optimized. But we can try, we can see. Let me just change my headset type here so I can actually hear myself speaking. And here we go. So yeah, let's actually begin. First of all, let's open an SSH connection to my Raspberry Pi, and we're going to be creating the sort of directory where we're going to be pasting all the source code, right? CD development. I've got muscle memory here. I'm going into the project at work, which starts with, I guess you've seen it's PL. And let's create a directory here. I don't know what to call it yet, but let's just audio visualizer on the stream. I don't know. Let's just call it audio visualizer for now. We can then kind of think of a different name, a more friendly name if we release this on GitHub. So yeah, I mean, this is what we are. Ideally, I'm going to have a CMake list as well here. And I'm going to actually steal some of the stuff from a different project. So Base64 it's kind of like a very complete project that I've got on GitHub at the moment. It's just a base 64 encoder and decoder, but this has a very good setup in terms of having all the CMake presets there, having all the CI/CD stuff that I may need for this project, and also the presets sort of integrate very well with Conan, and Conan is what we're going to be using to basically grab all our dependencies. So I'm going to steal at least the CMake presets here. I don't think there's anything else I need to steal for now. Maybe just the Conan file as well, just so I can start with the base. So yeah, let's do that, and I'll explain. So let's just copy base 64, CMake presets into here, and we're going to do the same thing for the Conan file. Conan file.txt into here. Cool. Now I can go over to Visual Studio and actually open this directory in there. I don't want to open the previous Rust one that we were writing yesterday. We're obviously going to continue with the Rust streams in the future, but I just thought I would have a break, maybe 1 or 2 days from Rust, and see how popular the C++ streams are compared to the Rust one. But anyway, so yeah, we want to basically open a window, SSH, reload window, open active host. I can't remember what the Visual Studio code, there you go, active file. I just want to open a blank window so I can select the directory. That did not work, right? It did not work. It was something to do with active host. Terminal, active window, active file. No, we don't want that. How do I do this? How do I open a different directory on the remote SSH extension? Connect current window, add a new host. Focus. Still hope you're well, bro. Oh, Slim. Hi, man. Very nice to see you again, dude. Yeah, I'm doing good, man. I'm doing good. Just working, you know, as you probably are too, I guess. And after work, yeah, we try to do some of the grinding here on personal projects. But how is it going for you, man? How are you doing? I'm just struggling with the remote extension now, trying to open a different directory on Visual Studio Code. So current connect window to host, connect window to host. Gosh, why is it so difficult? Open active file in Windows. That's not what I want. Try my remap to remap my new mouse with keyboards when using C++. Oh, nice. What library are you using? Are you just? I don't even know how you'd begin that, to be honest. I've never tried anything like that, to be honest, with C++. Open workspace from file, open folder. Oh, there you go. Ooh, that was difficult. Development, and we want to go for audio visualizer. Cool. Gonna have to retype the password. New C++. Ah, okay, cool. So you're also new to C++. That's good to know. Maybe you'll learn one thing or two from here, from this video. Yeah, as far as I know, I'm not sure how you'd be able to remap buttons. There's no library that comes up to my head, like up to my mind. I mean, you could use the Windows. I mean, I'm assuming you're a Windows, right? There's the Windows API that might have something to do with the events that you can catch the events that are released when you type in a mouse button. But that's a very difficult path to take, though. I'll definitely look for a library to do that. Linux, okay, that might be easier then. That may be easier. Yeah, I mean, as far as I know, you can remap keyboard on Windows, on Linux. I've seen people doing that before. You have to use something like the Linux headers, I guess. trying to see here if there's something that I recognize, but that should be easier. Linux generally is easier for remapping things. But yeah, man, I'll let you do that search. I don't want to waste too much of my time now. But yeah, basically you're going to be listening to the events and then remapping them. Anyway, so now, where was I? Trust the authors. I've got a CMake list here. What I want to do is I want to create a new folder called source. We're putting out the source file here. Thanks, bro. Doing it now. Yeah. Let me know if you get anywhere, dude. I'm quite interested in knowing how you're going to do that. So let me know if you find anything useful. But yeah, generally try and find a library that already does that kind of stuff and see if it's cross-platform, because it might work on Windows as well. And if not, your last resort is to actually sort of go into Linux events, basically. But that's, you know, kind of difficult, but you can do it. It's doable. Let's add an audio visualizer and then another CMake list in there. So this is what's going to hold our audio visualizer exe. Add in the executable here. I'll just call it visualizer. Comprises of the main.cpp file. Cool. I do need to do the find packages to include OpenGL and things like, I don't know what else I'm going to need, GLFW for the window. Actually, this is GL, like glue or something. Yeah, so let's begin. So we've got an executable. We don't have the main file. Yeah, let's add that. Main.cpp. And in here, we're just going to put, just to compile, a main here. Standard cout. Hello world. Yeah, there you go. And in this file, we actually have a few things to do. I guess we need to do the CMake minimum required version. I want to work with a fairly recent version of C++ and maybe use some of the experimental features in CMake later on, but for now, I don't know. Let's see, CMake. What are we on? 3.27. We can do 3.25 then, right? Everyone should have that version, at least. And then we also have the project. Okay, cool. And then we're going to set the CMake minimum required version, and then we do something like 20 or something, right? Let's compile it for 20. CMake cxx minimum required, it should be standard, sorry. CMake cxx standard required. We're gonna say yes, and CMake cxx. Thanks, bro. Yeah, if you're doing something with CMake, which I recommend, by the way, using CMake to do your build files, don't forget to set the CMake C++ standard functions, just to make sure that you're compiling with the right version, or the version that you think it is. Extensions, let's turn that to off. And then we add subdirectory. We've got src, audio visualizer, right? Cool. I mean, we should be able to select a preset. So if we do Unix make debug. Yeah, I'm doing that. Learn that from your previous video. Yeah, thank you. Well, today you're going to learn Conan, which is, I guess, does the same thing as VC package. It's a package manager, but it's a little bit more customizable, and I prefer Conan than VC package, to be honest. So right, let's see what's going on here. Could not find toolchain file, Conan toolchain. Yeah, that's because I don't have a toolchain file yet. So Conan, you know, as an easy explanation, is a package manager for C++ as well. And as far as I know, it was written in Python. I'm not sure if it still is. So, you know, you kind of do need Python. In fact, yeah, let's have a look. I think it is entirely Python still. But it has a lot of it's very customizable. Like you can cross compile, you can kind of go and look at the recipes yourself fairly easily. You can do that in VC package as well. And for me, it's just easier for me to understand what's going on with Conan than VC package. It's less hidden. But anyway, yeah. So what do we actually need? We don't need gtest at the moment. Yeah, and you know, declaring dependencies with Conan is very easy. You just need the Conan file.txt, and the rest is just on the command line. You see me doing it in a bit. I want to go to the Conan center and see the stuff that I need. So I'm gonna be looking for basically the third-party dependencies that I need. Like for a fact, I need glue for the OpenGL extensions, right? So I'm gonna use that. I also need GLFW. Just for a lightweight sort of cross-platform window management, I guess, so I can create windows. And what else do I need? I think for now, that's it. I'm gonna also include FMT because I like having that library there for logging. We can worry about different things later. So I'm gonna use FMT10. Let's put that here. We're going to be using glue 3.3.8. And recently Conan had a massive sort of rework. So they went from 1.0 to 2.0. They reworked basically a lot of things. Certain things are more efficient, certain features. But that means that the Conan 1 recipes aren't compatible with Conan 2. For some of the recipes, I guess, not all of them. So I was kind of basically just waiting for that change to be a little bit more concrete before I do a video on Conan. So you might see a video on Conan, you know, in the next week or so. Vinay Sharp, hey Vinay, how's it going, man? Good to see you. I think I'm getting a little bit of delay between getting the messages and reading them out to you guys. I do apologize for that. There's just a stream delay for some reason. Oh gosh, so yeah, we're gonna need glue, as I said here. And glue is for OpenGL, for the OpenGL extension wrangler, so I can have the OpenGL functions. And then GLFW, as I said, just for the window and events, like keyboard events and stuff that he catches. I think that's most of the stuff now. And the rest is just, you know, pretty standard stuff. Fine, how are you doing? Yeah, I'm doing very nice, Vinay. Just a little bit tired from work, really, but you know, I can always stream at the end of the day. So today we're going to be doing some C++, as you can probably guess here. Yeah, so now let's actually run the Conan command, right? So, like once you declare what dependencies you want in the Conan file.txt, you have to basically pull them with Conan. And Conan is just a command line library. I personally installed it with pipx. So if you do pipx install Conan, that will get you the latest version of Conan, which at the moment is like Conan 2.1 or something, right? Conan, let's have a look. Yes, 2.0.11, sorry. So we're not quite there on 2.1 yet. But there's been 11 revisions, 11 patches to version 2, which is very good. And installing the dependencies is very easy. You need to do a Conan install. You point to your Conan file, which is basically just in its directory. And then you can say kind of like what... John Spenny. John Loopy. Hey Loopy, how's it going? Nice one. When do you need a benchmark? Dude, maybe we can benchmark this when I guess we have something working. For now, this is just a start. So yeah, we're going to include like Google benchmark or something like that. Especially if I decide to implement the Fourier transform, which is like the the mathsy bit, like the bit that analyzes the audio and shows you the frequencies. I can write that and then compare it to a third-party library and see which one's faster. That would be a cool exercise, but this is not going to be today, unfortunately. Today we're just setting up the project. And yeah, how is it going, John? It's good to see you, man. Good to see you. I hope you're doing well, man. So Conan install, debuild. Yeah, as I was saying, installing dependencies is very easy. Just call Conan install, and then you can pass in some settings. Like if I want to make sure that Conan builds all the dependencies in debug, I do a build type equals debug here. And I also need to say where Conan should put the CMake integration file. So that is the toolchain file. It creates a toolchain file in the same way a VC package does, right? It's the same thing. Yeah, because I've got the CMake toolchain file here and CMake dependencies. And for that, I'm just going to do output folder, just put in Conan debug. And I want Conan to actually also build the missing libraries. So the difference between Conan and VC package is that Conan doesn't always build everything from source, right? So for example, if you're pulling a library like, let's say OpenSSL, very big library to build, I say, right? Not as big as Boost, but still fairly big. But your computer, your build settings match someone else's build settings, and that person has pushed it to the Conan center, you will just download the pre-build file, so you don't have to waste time building. And this flag here, build missing, is just going to tell Conan to build, to only build dependencies that haven't actually got my configurations on the remote, right? So it's not going to build everything. But that's basically it. So you can see here, it's pulling the dependencies. Hopefully nothing's going to fail. You know, every now and then you do get a few failures with Conan, but you know, this is what we got, like this. OpenGL system, error in system requirements. This is to do with, I guess, a system requirement that I don't have. So I have to install something on my Raspberry Pi. For example, libgl dev and libgl mesa dev. So these are things I don't have installed on my system that I required for this package. So you know, it's just a matter of me doing apt-get install there. And if you run Conan with sudo as well, you can do this automatically. But I don't really want to do that, so I'm going to do it manually. Okay, so let's install them. 157 megabytes of dependencies. Quite big for an OpenGL. The Mesa drivers, I guess, right? The debug drivers. Sorry, the developer drivers. Or developer libraries. So once we do this, in theory, it should work now. Only if the recipe has listed all the dependencies that it needs correctly. Because sometimes the recipes don't actually list all of the dependencies that, you know, your library needs. So I might have to install another few ones, but we'll see now. If it fails, we'll know why. There you go. So we have got more packages that I needed. And this time, you know, there are quite a few. Conan, not that many actually, I guess. Let's just do these for now and then see if we need any more. We're gonna have to reformat some stuff here. Okay, there. Trying to keep an eye on what kind of stuff it's asking me to install as well. Make sure it's not too much. These all kind of make sense, to be honest. Yeah, the reason for, I guess, Conan asking all of these graphics related libraries is because my Ubuntu has, my Raspberry Pi has an Ubuntu server installed, and that doesn't really have a desktop engine on it. So like it doesn't have the X server or anything like that. So I might have to install quite a few things actually. Which just made me realize that I'm not actually going to be able to run this because I'm running remotely, which I guess is fine. I can just, on the next stream, I can just compile this code on my machine and then display that. But yeah. There you go, there's even more packages that we need. X1 dev. Which ones did we install? X11 dev is here. Phone tech, okay. Conan exception, system requirements. I'm missing, but can't install because, okay, let's just get these ones then. See, as I said, quite a few libraries that I'm trying not to install, but unfortunately need to be installed. And it may be the case that I'm going to spend like 20 minutes just installing everything. But that's got to be it, I guess, right? Let's just hope all these libraries are actually in the Raspberry Pi repository. The chat has kind of like died. I'm not sure if it's not updating for me, but I haven't seen any messages in a while. So if you guys are talking, let me know, please. Somehow, maybe on Discord or something. Okay. I'm here. Okay, right. I was just wondering if it's frozen because I have to kind of, I guess, restart the chat window. But thank you for confirming. A lot more libraries. What I could do as well, since this is, if I want to do this remotely still on the Raspberry Pi, I could get an X server installed and then remotely have the desktop on my machine just so you guys can see the window and stuff. I think that might be the way actually. Let's actually look into that in a bit. Just gonna leave the window open here. Yeah, so we're gonna need something like this basically. Install a display manager. Install GUI on Ubuntu server. Yeah, Ubuntu desktop is the one I need actually. And then I guess I'll be able to connect. I think it's graphical login. Yeah, there'll be a graphical login, I guess, but I need to look into how to do that later. Right now, let's just try and compile all of this. Where are we? Now, can we finally install the Conan dependencies? We shall see. We've installed everything it asked so far. There you go. Now it's getting all of it. But it's missing a few still. The only, as you can see, the only downside is that it doesn't say all of the stuff that you need straight away. It does like one library by one package by one package, which is a little bit annoying, but we can do it. I'm missing kind of stuff because tools, yeah, sudo. Okay. Now let's try again. Another one. Sudo apt-get install. And the reason why I'm not letting Conan install all of this automatically is because I can't run Conan on sudo because it's only on my path as a user, and I haven't set up Conan for sudo yet, and I don't want it to mess up my my other packages, so that's why we're taking the longer, I guess, CMake route. There you go. Finally, now it should be good now, right? Yeah, there you go. Now you see it's actually building, which one is this? This is the FMT library, the formatting library. So it's building that from source. It's checking something else. A lot more output than VC package, I gotta say though. And then GLFW. This is for the window management. Okay, so it's building that from source as well, because apparently no one's pushed the build for, for Raspberry Pis yet, so. And you know, this is kind of what Cargo does in Rust. So Cargo manages all the dependencies for you by itself, really. But you know, Conan kind of does that. And now that everything has been installed successfully, if I go into the Conan debug directory, you can see that I've got a bunch, you know, quite a lot of files here, which basically let us integrate our libraries with CMake. But now also I can reconfigure. And because I've already set up this CMake presets here for Conan in one of my other projects, you know, I can share that with you guys. I already have CMake kind of integrated here, and all you have to do is basically to pass in the CMake toolchain file and point it to the Conan CMake toolchain file. In my case, it's my source directory, Conan debug, Conan toolchain file, which is this file here, as you can see. Let me just find it for you. There. So, you know, this is the behind the scenes here. This is what you have to do in CMake to make it work with Conan, to make Conan work with CMake. The rest here is just all from my base64 project. I'm not going to go too much into detail. You can probably look at my GitHub, and there is the base64 project on my GitHub, and you can look at this particular file in there. But it's, yeah. So let's try and actually use one of the libraries that we pulled in our main thing here. So for example, let's include FMT, right? So we want to include FMT here. Now, before we do that, we have to look at the CMake lists for this particular project, for this particular executable, which in my case is located at source audio visualizer CMake lists. This is what's declaring that executable visualizer, which, you know, comprises of the CMake, the C++ main.cpp file. Now in here, what I have to do is do a find package, and then I can do FMT, and I can say I want this library to be required. If it doesn't find it, it's going to fail. And you can see here that when I save the file, Visual Studio is automatically going to reconfigure, because that's what it does. And it did find FMT here. As well as that, I want to make sure that I say target link libraries, and I've got my main or visualizer. I can't spell today. Visualizer. And I want to make a private target, a private dependency, and I want to say this is related to fmt.fmt. And this is basically going to link the FMT library to my visualizer library, my visualizer executable, right? So now if I come in here, I can say include, and I should be able to see FMT if it worked fine. There you go. And I've got format, right? So yeah, I can do something like stdcout fmt format, arguments. Let's just pull the arguments there. Actually, let's not put any arguments yet. Let's just say hello world. It's a lazy way of doing it, literally using a string literal, but yeah. There you go. This is just going to use the formatting library just to make sure it's linking. I just want to make sure everything works fine. And if I do a build, a clean build, there you go, everything works fine. And also if I go on the terminal, everything should have been built by default in this particular case here under build Unix debug, because that's what my preset says. So if I go to build Unix debug, I will find source and also visualizer here. And then inside the other visualizer, I can do visualizer, and it says hello world Mateus. Okay, that's my name. Yeah, it just means that the formatting library worked. And now we can kind of do the same for, I guess, GLFW and glue, right? So it would be nice if we can show a, I guess, a window, right? So let's aim for that in this stream. If we can show a window and maybe display a triangle, I'll be very happy. because OpenGL is quite difficult, and since I've not done it in a very, very long time, I'm not gonna be able to do much today, aside from just doing the basic things. Now, GLFW is not found. Why not providing find GLFW? Because it's a different name, as you can see here. It's called GLFW3. So, and I guess it did say that on my Conan. Yeah, right. So if we look into, yeah, it doesn't. They need to improve the documentation here, because FMT has the code snippet and how you can include the package after you've downloaded it with Conan, and the GLFW description does not. So they need to definitely improve this. Does glue have it? Nope, does not. But yeah, we don't really need to know much. But what it does say is that it does show you the CMake targets you need to basically include in your executable or library in order to be able to use these libraries. The CMake is going to log that out for you. So, for example, if I want to use glue in my main, I have to link against this target here. If I want to use GLFW, I have to link against, where was it? I guess GLFW, right? So that's what we're going to do. We're going to link against those two libraries that we found. So glue, and we also have, I guess, GLFW here. Okay. Now, this is, I guess it is going to compile, and I could basically just go online and get a very easy code snippet to create a window of GLFW, right? And let's try that. But basically, if I go in here, I should be able to see GLFW now, right? Or maybe, yeah, there you go. GLFW, GLFW3, and I can also include GL.h. So this is just going to put a comment here so you guys can see for now. This is glue, and this is GLFW. And let's just look at the code for creating windows here. Now there is an option, there is an init function somewhere. So in my main file I could do GLFW. GLFW init. I think I have to call that first if I remember well. So this is going to initialize the GLFW library. This function initializes the GLFW library before most GLFW functions can be used. GLFW must be initialized, and before an application terminates, GLFW should be terminated in order to free any resources. Okay, so this returns true. Let's see, you should call GLF terminate before the application exits. So returns GLF true if successful, or GLFW if false. GLFW false if error occurred, right? So let's do an if here. So if GLFW init returns true, or doesn't return true, right? We don't only care if it doesn't work. We're gonna do a cout here. And what's the issue? Expected a... Okay, yeah. I'm no longer in Rustland, so I need I need to do proper C++ now. So cout failed to initialize GLFW. We're just gonna do a print the stud out now. And now in here we do a GLFW. Is it terminate? Yeah, terminate. Okay, we don't care about the return value of that because it terminates anyway. Now I want to create a window, so I'm going to use this. Yeah, if you look here, the GLFW create window is the one that we want to use because it is the function that creates a window in any platform. And yeah, So we have the create function, and if this is a C library, a very well designed C library, there's going to be a terminate function as well. Right, so we have create function. Do we have a destroy function? So GLFW destroy window. There you go, and we take a window. Okay, now this is obviously a C++ library, right? So sorry, this is obviously a C library. So it would be nice if we can wrap this into a unique pointer, right? So we can do a little bit more modern C++. And yeah, let's try that. So basically what we want to do is we want to kind of end up with a unique pointer of window here, GLFW window. That's going to be a window, and we want this pointer to sort of self-destruct as well, right? So we need to basically create a custom deleter for this pointer, this pointer type, which is just going to call the terminate window, right? So let's see how to do that. I keep forgetting how to do it. Every time I have to do a custom deleter with unique pointer, I just forget what it is. So unique pointer, yeah, and a deleter. Okay, cool. Cool. That's the syntax I wanted. So what I can do, I guess, is I can do a namespace here, just to keep the helper stuff, right? Just for this file. We can then put in different files later, and we can do a using window pointer equals, and that's the unique pointer of GLFW window. There you go. And we also want the destructor type, right? So and what is this? This is a void. It's going to be a void function that kind of just takes in, I guess, a GLFW window type. Okay, cool. Yeah, cool. So that's a window type, and we can also have a function that will create the window, and that can return a window pointer to us. My eyes when you open Stack Over. Oh, sorry about that, dude. Yeah, I can see now. My eyes are the same, don't worry. It's not just you. You don't use dark mode. I do. I've got dark mode everywhere. These websites are not working, I guess, but if you look at my Google, it's in dark mode. Must be bugged for me. Sorry about that. I will reinstall it to see if it improves. So this is going to create a window, and it's going to just return a window pointer. And what do we do here? This is very easy. We want that window. We definitely want this, and we also want to return the unique pointer. I think has to be unique pointer. Wait, can I just use the initializer list? Is it going to work? I'm wondering. If I do window here, and also this is not going to work because lambdas don't really turn into function pointers, right? So what do we want? We can just do an auto destroy window. And we're slowly beginning to encapsulate the GLFW library. So what we want to pass in? We want to pass in the window GLFW window here. And if we want to say if the window is somewhat valid, right, we want to do a GLFW and destroy window. That's all we're going to do. Now I want to see if this works. Yeah, this works. This works fine. So yeah, just I guess, is it better than just using the functions here? I mean, there was a lot more code than me just using the functions, but at least I can do something like this now. So auto my window is equals to a create window, and that is it. And I know for sure that this is now a unique pointer, which means that the destructor will happen whenever this runs out of scope, so I don't have to call terminate in here, right? Even better if I return early, like if I just have an early return for this function or something, this will, you know, work automatically for me as well. Now I want to not hard code these things here, so this is the width, I guess the height here, and then the title of the function. And I'm going to leave those two as no. I don't really know what they are. Can you see? So monitor and share. Okay, so the index monitor and the window share. What's that? Okay, there's a lot of remarks here. The windows, whose context to share resources with. The monitor to use. Okay, or no for windowed mode. Yeah, we want it windowed for now, and we don't really care about the sharing stuff. So let's do a, what's this supposed to take? Just an integer, yeah. So we have int width and int height there. And let's do string const title, right? With me being a new SE learner, currently exploring Emacs and other tests editors. Holy hell, these sequence and typing skills of yours seem to be scattered in my eyes, but I still want to be here. I don't know what you mean, dude. I mean, are you saying I've got good typing skills? I don't think I do, man. I just barely get by. But thank you anyway, thank you. And yeah, it's good. Welcome to the stream, Peter. It's nice to see you. So what does it take this? Okay, let's just do a C string there. And let's also include string here. Okay, what do we have? Yeah, so now we can actually, yeah, so I already got my first mentor. All right, I can help you out as well, dude. If you stick to the streams, you learn something. Just subscribe. Thank you very much. Thank you for the subscription. My goal is to reach 1,000 by the end of the year, but it's going to be very difficult. I have to get like at least 5 subscribers every day, and my average is like maybe 3 subscribers a day, so still under the average. So width 640 by 480, I think it was. And then the title here, let's call it my window. Right, that's what we care about. So you know, in theory, we should have a window up here now. We should have a window. However, we need to make sure that we close it as well whenever we want to just not run anymore. So let's see, GLFW window hints. We need hint as well. because hints will say what the OpenGL type is, I believe. So we definitely need to have this page open in here somewhere. So maybe no, maybe we don't need any hints, right? Wait, there you go. I thought we needed to say what OpenGL version we have, but maybe not. But let's keep that window open. But I also want to know how to just keep the program running until we exit, right? Because we have to catch the event for when you close the window, and then you can finish the program. So yeah. So an error callback. Do we want an error callback if any errors happen? I guess we do, right? So I guess we can follow this as well. So we can have the error callback here, void error cat inscription, and we can just have let's change this from fprint to just a std.cout with fmt format. Error. And then we're going to have description. Cool. Yeah, let's set the error callback. So we do that there. Let's just copy this and paste it here. Now, what does this return? Does it return the previously set callback or null if no callback was set? Okay, we don't really care about the return here, do we? So if it doesn't set the callback, oh well. I guess we do care. Let's see. Just to make sure, it does return. Yeah, if it's null, so if this does not return true, we have to say that we haven't managed to set the callback for the errors, right? Cool. So we need to create a window. We need to see if no window is open as well. We need to exit the program, right? That's a good point here. So we can say if there's no window, we're gonna just print out, failed to start window. And we're also going to return something like -1. We don't really care now. Okay, and what else do we need? There you go, that's what I meant. So we need the OpenGL versions here. So we need the major and minor versions. I think I'm going to set it to 3. GLFW wins, okay. And that has to happen before we actually do the window from the looks of it. But we can put that in the window creation, right? So yeah. Let me just see if we can major. I think 3.2 is a fairly standard one. I want to use OpenGL 3.2. 2.0 is kind of too old. It's like the old pipeline, so I don't want that. And then destroy the window. We already have that in the unique pointer. Make context current. Before you can use OpenGL API, you must have a current OpenGL context, right? Yeah, so we're gonna have that, I guess. OpenGL, let me Google that. OpenGL is just, well, it's an old library that does graphics. That's basically it. Most games back in the day were created with it. Nowadays, not so much. People use, I guess, DirectX, or even just straight up engines like Unreal, Unity. And also, if you want to go down to the driver, I guess. If you want to manipulate the drivers, you can do Vulkan, which is like the successor to OpenGL. But OpenGL is very easy compared to Vulkan. So we're going to use that to just render a window here. Okay. Glad load. Okay, so we don't extension library. And now the thing I have to do is to initialize GLES. So GLES is the library that's actually giving me the OpenGL functions, right? So it stands for, I think it's GL extension wrangler, which basically just means that this library, once you include the headers, you will find in your machine all the pointers to the OpenGL functions, because your machine already has it. You already have OpenGL drivers installed. So all that is left for the program to do is just to find where those functions is, and that's what GLES does, right? That's what glue does, sorry. GLES is a different thing. And I believe I have to initialize it somehow. Maybe not. So there you go, initializing glue. First, you need to create a valid OpenGL rendering context and call glue init. To initialize the extension entry points. If glue init returns glue OK, the initializer succeeds. Okay, so this is basically what we have to do. So we create a window with glute, and then we create glue init. So after the window creation, let's just call this window, right? It's not our window, it's just a window. We need to do a glue init. GL glue, and then glue init. Why is glue init not showing up here? Ah, okay, that's why. It's because I haven't included GL. Glue. There you go. Do we need this for now? I don't think so. There you go, glue in it. So if we can see what this returns again. Oh, this is a little bit less friendly because it doesn't actually have any documentation, does it? Oh, that's interesting. Peter, oh, that's interesting. Then probably Mario was created with OpenGL. I mean, maybe Mario 64. Not entirely sure. But you know, the older Marios, not even, that's before OpenGL as well, my dude. That's before OpenGL. OpenGL is like for 3D, basically. You know, if you're talking about Super Mario World and Mario Bros, these were just, you know, straight up assembly code. Much harder than this, much harder. So if this does not return something nice, we're gonna say that we failed. Let's initialize glue. And again, we're going to return a -1. Why not? So yeah, I mean, in theory, we've got everything we need to get this running. Now, the only problem is that I can't access my expected. Wait, can I build this? Yeah, the only problem is that I can't access the GUI on my Ubuntu. And this built just fine. I don't know why that's still there. There you go. So this build just fine. So in theory, we should have a window that's 640 by 480 pixels big, but I won't be able to see it because, as I said, I'm on my Raspberry Pi here, and I've remote SSH'd into it. But what I can do is I can maybe install the Ubuntu desktop. On my Raspberry Pi server. As a lot of shit, guys. There's a lot of shit. 2 gigabytes. Yeah, why not? There's 2 gigabytes of dependencies. And once I do that, my point is that I will be able to basically remote into my desktop environment, right? So let's have a look. Ubuntu remote desktop environment. That's what I'm trying to do. And I'm on 23.04. And we have a server world here. Okay, so it's just a matter of installing this, I guess, and enabling the service. And then from Windows, we can open a remote desktop connection. Okay, yeah, let's try that. But the problem is, this is going to take a while. This is 2 gigabytes. Yeah, my internet isn't that bad, but yeah, guys, this might take a while. In the meantime, what can we talk about? Yeah, so let's just do a very quick summary here. So since the beginning of the stream, I've created this directory which holds some source code for an audio visualizer, right? And essentially we have a kind of functioning CMake build here for a one executable called audio visualizer. And this audio visualizer is just compiled from one file called main.cpp. And that's what we've been editing for most of the stream, actually. But aside from that, we link a bunch of libraries to it. So we're using a bunch of libraries in this main.cpp. In particular here, we've got glue, we've got FMT, and we've also got GLFW. GLFW is for the window management, so I can create a window in a cross-platform way, and it's very lightweight as well. I've used it before. It works for Windows and Linux. FMT is just, formatting for logging, I guess, stuff. And glue is for the OpenGL extension wrangling, so I can access OpenGL on my code. So Peter again, that's you install it. So that's you installing on Ubuntu. Yeah. So this is me installing shit on my Raspberry Pi, which is running Ubuntu 23.04. This whole coding exercise here is done remotely on the Raspberry Pi. I'm not actually running on my Windows. This code is not on my Windows machine, and so is the building. The building is all running on the Raspberry Pi. This is just so I have the same experience on. I've got my main laptop here, and I've also got like a tablet and a different work laptop, so I can log into it every time and access the same code and access the same builds. That's why I'm using the Raspberry Pi. Just a nice exercise to have. Now going back to the summary, yeah, I mean our code seems to be compiling, and this is after we've pulled all the third-party dependencies with Conan, and you can see here that I'm pulling FMT, glue, and GLFW from the internet. I'm not actually downloading these libraries myself and putting them in a random place in my machine and then including them in my build. Conan is doing all of that for me. And yeah, this is where we are so far. And we've essentially compiled here some code that will create a window. And I want to see if the window exists, but as you probably know, I can't see windows on the terminal. For that, I have to actually have access to the desktop environment, and hence why I'm installing all the desktop stuff for Ubuntu here, which may take a little while, guys, and I do apologize. It will take a little while. So in the meantime, I'm gonna keep this on the side so I can track it. Is there anything you guys want to look at together, or perhaps we can see what the news are, right? Let's read some hacker news just to kill time. Let's see if there's anything interesting in the world of programming. Right, so while you talk about your live streams, can you also be specific on days you do stream? Oh, Peter, man, I've been streaming basically most days of the week. There's no I don't have a schedule, I just stream when I feel like. But this week, for example, has been pretty much every day since Monday. I do usually take a break on Sundays and I guess Fridays, because Fridays aren't a very good days to stream. I think everyone is enjoying their time with their families or their partners, so there's not many people watching. So yeah, Fridays and And Sundays I usually take a break, but yeah, on the other days you can either find me here on my Discord or on my Discord. So if you want to join that as well, feel free to join. I tend to have that on my phone so I can see the messages all the time. So where are you from, Peter? Where are you speaking from? It's good to know where my subscribers are from. So Dino Q's, Judge rules out. I do have classes and I want to be here most. Yeah, man, definitely focus on your classes, dude. Don't worry too much about watching my streams. They're on YouTube, so you can watch them later if you want as well. Shouldn't be your priority. Focus on your studies, man. That's what's gonna help you out. So you're at university then. So GPT-4 generates a simple app from whiteboard photo. I mean, it's getting kind of tired now seeing people create apps with GPT-4. Writing a debugger from scratch. Now this sounds interesting. This sounds interesting. Not so boring. I did this with a progress bar that actually like view meter. So not so boring. What do you mean you did this? Like an audio visualizer? Is that what you mean? Did it with GPT? Oh right, you did it with GPT. I see. So you're talking about this. GPT generates a simple app from whiteboard photo. Do you have the app up available somewhere so you can take a look? Happy to. It'd be cool to check it on stream, see if it works here for me. So yeah, writing a debugger from scratch. This guy has big balls, man. Debuggers are very, very difficult to write. The last post we started to get some interesting functionality with the ability to resolve addresses to names in a module. This was the last functionality missing before it could implement breakpoints. This part adds the ability for debug RSs to set hardware breakpoints. The code for this post is 25 on GitHub. I'm gonna try. So what is this? This is. So he's using Rust to write a debugger. I kind of just want to see how big this file is. This project is. It's not that big actually. That's pretty cool though. Evaluating symbols when setting breakpoints expected. I mean, this is cool. I'm definitely gonna read this on my own. Yeah, I don't think it's very interesting to kind of go through all of this code on stream. Not so boring. It was a simple progress bar displaying volume intensity. I gave up on the feature. It was making audio players slow. I didn't know how to make it play another thread. Going on. Nice. That sounds very interesting though. Is your player, did you write the player as well? Like, do you have that code up? Is it a C++ code base? Is it, what did you write it in? I'm kind of interested now. Okay, so we're still installing Ubuntu desktop, so we can just see the window that we created, guys. This is crazy. It's still going. Yes, I did C#. Nice, nice. I don't really know much C#, but from the C# code that I've seen, it tends to be pretty readable, right? If you write good C#, even to someone who doesn't do C#. I wish that's one of the languages I wish I did, because there's definitely quite a few jobs out there in C# that pay really well, so. Journey into shaken baby syndrome. Work as AI serverless, GPU powered inference. Gentle introduction to static analyzer for C. It was very difficult, but GPT helped. Yeah, I mean, GPT is great for that kind of stuff. Like when you just want to get like a code snippet and you go on and be like, yeah, can you write me some C++ code to do this? And it just works somehow. It's crazy. I mean, somehow works. It just looks at a lot of projects that are very similar and then just kind of copies them, but still useful. That's what we do online anyway. The conscience of a hacker, chilling the plunge. Not necessarily anything interesting I would like to read here. Your nines are not my nines. Be careful. My books were used to train. Oh, this is interesting. My books were used to train a generative AI. Good. I mean, most people would be like, not good. And we're still installing all the stuff. That's fine. When The Atlantic revealed last month that tens of thousands of books published in the past 20 years have been used without permission to train Meta AI's language model, well-known authors were outraged, calling it a smoking gun for mega-corporate misbehavior. Now that the magazine has put a searchable database of affected books, the outrage is redoubled. I would never have consented for Meta to train AI on any of my books, let alone 5 of them. Yeah, the original Atlantic storage. Okay, cool. Oh no, I hate these. I hate when you have to like subscribe to read the whole article. I don't even want to read this anymore. But it seems like this guy kind of lets the Meta's AI. Oh, it's fine with Meta AI training their stuff on his books. I personally would not, to be honest, because it's kind of stealing your creativity, right? That's right. GPT blew me away. Help me understand coding better than a stranger. Yeah, I mean, I agree with you. Not so boring, because I tend to use GPT to explain certain pieces of code that I don't understand, and it's surprisingly good at that. Like, especially when I'm still learning Rust, for example, and many things in Rust that I don't understand can just be explained by GPT quite well. So it does save me having to read like an entire like 30-minute long article. So yeah, so you can use 12 feet ladder to read this article for free. Interesting. What is 12 read? Is that illegal? 12 foot ladder. Is it a free website? Show me 10 foot. I'll show you a 10 foot ladder. No way. Oh my god, yeah, this is a... I'm not going to use it, I mean, but I kind of understand it's the same as the papers website. I forgot what it's called now, but it was like, you know, if you're at uni here in the UK and you have to write something, you have to cite your papers, right? But to be able to cite the papers, you have to read them in the first place. And there was a website that just gives you the papers for free, even though you might have to pay them in other websites. But yeah, this is kind of the same. It's cool, but I'm not going to use it on stream. I don't want to get banned by YouTube. But good to know that this is there. Good for teaching people. Yeah, indeed, GPT is definitely good for teaching people. We seem to be nearly done now with installing Ubuntu Desktop. Paste your URL. Yeah, no, I'm definitely going to paste it off stream, but I don't want to use a potentially illegal system here on YouTube. I don't want to get banned. But you know, then you can read it for free. Yeah, I understand, Slim. I definitely like it, by the way. I just don't want to get YouTube to ban me. That's all. All I'm trying to do now is basically just connect to my Ubuntu. But this is taking some time. It's definitely taking some time. I installed so many things, so many things. Suggested. I hope it was all worth it. I hope it was all worth it. Now we can also look at some code. Sorry, this is delayed. Yeah, this is very delayed. Very delayed. I do apologize. I think it's on my end. I don't know why. So what are you doing? Like VU meter, multiple frequency visualizers, LED style. Curious what it would look like. So my idea is, this is not going to be finished in this stream, by the way, because I'm going to probably do another like 30 minutes and then I'm going to go. But is to just have a I guess a wave parser and an MP3 parser. So we read the audio files and then analyze each sort of window with just discrete Fourier transform. Just have a single wave analyzer, I guess, and show that as, you know, moving bars on a program. So that's my very minimum sort of viable project here. Broccoli, thank you, the Aquamarine Dragon. Thank you for the broccoli. So not so boring. Have you written audio visualizers before? You sound like you've got some experience in this, so you might be useful to me. I might ask you a few questions. But yeah, maybe I'm planning to use the fastest Fourier transform in the West. I'm not sure if I can actually get it from Conan. That would be interesting. you missed. I don't understand the aquamarine, but thank you. So fastest Fourier transform in the West is here. So there is a C library for it. I can use this to make the Fourier analysis for each window. So the challenge really will just be like reading the file and then reading every 10 milliseconds and showing the resulting like bars on the screen, basically. But yeah. But right now, I just want to see if my window creation worked. And I can't do that because I'm kind of remoting into my Raspberry Pi, and that doesn't have a desktop environment, hence why I'm installing the Ubuntu desktop here, so I can show you guys the window does work. Subbed, looking forward to see the outcome. I'm not sure it'll be useful. All I did was that progress bar with help of GPT. I was curious to see what it would look like. Yeah, if you tune in maybe like a week's time when I do a few more of these streams, we'll have something. These things generally take time. Like if you look at the, I was writing a Rust web crawler. It took about 3 or 4 streams until I had something that actually looks good and downloads images and stuff, which I'm still doing, by the way. I'm just taking a break from that project, but yeah, it's not straight away. Thank you, Not So Boring. Thank you for subbing as well, man. Appreciate it massively. Now, have we done yet, Ubuntu? Have we done yet? I'm not even sure if we're going to be done today. But so we don't waste time, let's look at some code to draw triangles, right? Draw a triangle with OpenGL. Chat isn't showing the messages. The chat is showing the messages, man. You can see it here on the stream there. I can see it, and I can definitely see it on my stream window as well. So now how to draw triangles, and immediately gives me a video on how to use a pencil to draw in triangles. That's not quite what I meant. Oh, I remember this website. I used it a lot back in the day when doing OpenGL. So yeah, I mean, ideally, I'm gonna have a vertex and a fragment shader. I don't really need a geometry shader at the start, but I do need to start writing the shaders, I guess. So maybe I can do some code to actually load shaders now, since we can't really see anything on Ubuntu yet. So yeah, why not? So let's do some code that will load shaders, and we'll kind of also compile them. Look on YouTube. I am. This is YouTube. Look, I've got the YouTube chat here, dude, and it's definitely showing up. Maybe you should refresh the page, like Control Shift and R. Maybe that will help. I don't know. But my machine, you know, if does everyone else have the problem? If you guys do as well, if it's not just the aquamarine guy, let me know, and I'll try and fix it. But yeah, going back to the code, yeah, let's do some code to actually compile the shader, right? So I'm very tempted to create another folder here just for the OpenGL abstractions. I'm trying to think here of the name for it. Let's just call it GL abstractions for now. Nope, chats are fine. Yeah, the aquamarine man, I think it's just you, dude. I'm sorry, I can't really help you. I don't know what's going on, but and I've definitely scrolled up, and there's nothing wrong here. Yeah, so let's. Yeah, I'm gonna move that. Let's put all our OpenGL abstractions inside this directory, this library, and we're gonna create a new CMake list here, .txt. And we're just gonna add a library called GL abstractions, and I don't know what we have now, but maybe we just have. We're definitely gonna have shaders, right? Shaders.cpp, because we're gonna abstract the shaders here. And we're also going to have a find package, because we want to include OpenGL here, right? Find package, glue required. Yeah, can't spell now. I'm using this like hand thing here to support my wrist, and it really doesn't help me typing, so I'm going to kind of remove it. You know, we're still installing things. We're still installing 2 GB worth of dependencies, so. Yeah, so let's add this there, and let's also add a new file. So the shaders.cpp, this is gonna be including our, you know, load or compile shader function or something from like a string or something, right? Just so we can have like the vertex and the fragment shaders. And if you don't know what shaders are, these are very important things in a sort of like drawing pipeline. So the shaders is kind of like what a little program that runs on essentially on the GPU that takes the vertex data, not just the vertex data, it could be like any kind of data you can pass into it, and then it creates basically a drawable kind of objects, right? So the vertex shader is gonna kind of just, you know, create basically like the wireframe information of it, and then the fragment shader is gonna interpolate that data and actually draw in the pixels for you on the screen. So yeah, check after the recording. Man, I don't know what you mean, dude. I'm sorry. I'm so sorry, the Aquamarine. If you've said something that I, you know, a question or something, you can probably repost it here and I'll try to answer it. Well, yeah, I'm sorry, I don't know what you mean. I've scrolled up and I couldn't find it. So yeah, let's continue. Yeah, but we also need to provide the headers for it, right? So we want to have an include and GL abstractions. And now we can put the shaders dot. Ooh. And this is where we're gonna kind of just we're gonna put our declare our functions, right? So we can include in other files. If and def. So what is this? GL. I'm just putting the guard here. So this file can be included more than once, really. And what do we want to do? We want to have maybe a function that returns either true or false, bool, called compile shaders, right, or something, compile shader. We want to take in some kind of like string for the shader data, right? And what do we want to include here? We want to include the string header, definitely. Cool. For the starting API, let's make sure we have this function there. And obviously in the CPP file, we can kind of like define this function, right? So provide a definition for it. But before we continue, I gotta make sure that the include header is part of this project. So I can do add target include directories, and I can do GL abstractions public include. This is just basically going to say that whenever I include the GL abstractions library into another target in CMake, all the headers under include will be available to me. In essence, like GL abstractions / shaders will be available in my other audio visualizer target here. That's the intention. Fun project, maybe for a follow-up, maybe a Rio view meets actual Legend series with parallel. Yeah, that would be cool, dude. I've got so many kind of like microcontrollers here, like the Raspberry Pi Pico, and LEDs that I can use to actually make a cool hardware audio visualizer kind of thing. Yeah, maybe we can do that as a follow-up. I don't really have a, what you call it? Is it an LED matrix? Yeah, I need to buy one because you can get pretty cool ones, you know, LED matrix that you can control with a Raspberry Pi or something, right? And then you can show the bars in here. That would be a cool project, wouldn't it? So it would be indeed a fun project, and it's not as difficult as you might think. GL is actually, in my opinion, you know, the more difficult than driving up a LED matrix. So, you know, the common part is both of these projects have the audio visualization, like Fourier transform bit, that are the same. So it wouldn't be difficult to turn one project into the other. So yeah, maybe that's a very good follow-up, very good suggestion. So right, so what's going on here? 100% agreed, yeah. My first job was actually maintaining an OpenGL like program for a company called Aviva. And it was quite honestly very difficult. More difficult than it should have been, because OpenGL documentation is very sort of difficult to read and heavy, so it takes a while. So what's the issue? Include errors detected based on the information provided by the configuration provider. Squiggles are disabled. Okay, I don't know why we are struggling here. Compile shader, compile shader. Okay, I don't know why this is complaining. Maybe if I reconfigure, it will stop complaining. Oh yeah, and we just need to add that library as well in here. So source GL abstractions. Now this is part of the main build. Cool, no longer complains. Yeah, this is like a very good point here that I want to make. This kind of shit, the error that you just saw, where he said that you couldn't find the header for whatever reason, it just doesn't happen in languages like Rust, because it has cargo, and cargo kind of like manages all of the Rust build system for you. So it also tells you exactly what the error is instead of giving you a false positive, right? This didn't tell me exactly what the problem is. The problem is my shaders library wasn't really part of my main CMake lists, right? So if I'm a newbie, I have no idea what it is. But that's one of the things I don't really like about C++, even though it still is my favorite language. We still have a long way to come. This is more like CMake related, really. But yeah. Right, so compile shaders. Now we need to go to a very useful website called docs.gl. And then we have GL create shader program, I think it's called. You can see it here. Oh, GL create shader. There you go. And I have a big neck pain. So this is the function that actually creates the shader for us, right? And you see here that it takes a shader type, because you can have, as I said, vertex shaders, geometry shaders, or fragment shaders. For the purposes of this project, we're only really gonna need the vertex and the fragment shaders. We don't really care about the geometry shaders. I'm not gonna go into detail explaining why not, but those are the the very minimum that you need for the rendering pipeline, the vertex and the fragment. Is there some code example? No, there isn't. But we can just use them. So let's take a look. So we definitely in here need to include the GL library, right? Because we're gonna use the GL create shader. Why is that not here? GL. Interesting. Did I include... Oh yeah. I forgot to do one major thing, which is to include OpenGL into my GL abstractions library. So let's do private. I think it's called glue, and this comes from Conan. And then we have, now we should have the freaking header in there, right? I still don't have it. GL abstractions private glue. What if we delete the cache and reconfigure? The header is there, so it is fine here. Now, why don't I have create shader? Ah. This is making me worried. Did I not set the right version for OpenGL? Create shader is crashing. That's not the problem I have. It's just not finding the image, the freaking. Let's include glue. Does glue bring that in? So we have all the GL colors. We have no GL create here. Ah. Why not? Well, let's write it anyway. And if it doesn't compile, it doesn't compile. Create shader. There you go. Now it finds it. Jesus Christ. GL enum type. This is GL. I think it's GL shader. GL vertex shader or something. He will say what it is here. GL vertex shader. There you go. Yeah, cool, cool. Now, if I want to completely abstract this, what I have to do is to actually provide some sort of like input here to say the shader type. You know, the type of the shader that I want to compile. And I can do an enum class here called shader type, but it just mimics whatever we have on the OpenGL side. We can have vertex. We can have fragment. We don't yet support geometry. Okay. And in here, of course, we can do the shader type. Cool. And now we basically select, you know, with shader, so kind of auto const and GL shader type. Just gonna select here the switch. The type, and if it's a shader type fragment, we're gonna return a GL fragment shader, and if it's a shader type, vertex, what am I doing? We're going to return GL vertex shader. Yeah, cool. I mean, is this more readable than me making a function call to get GL type? I don't know. Maybe we do that. Maybe we have a namespace here, just for the helper functions. So kind of like that. And that is it. That's basically it. Except, yeah, except we had that. So get GL shader type, and we've got the type here. And then in here we can have GL shader type. Now this returns something, right? This returns a UE int, so errors. This function returns 0 if an error occurs, creating. This function returns 0 if an error occurs, creating the object, right? So basically, if this has not been created, we can kind of like log this. You know, did not return a shader. We just want to, you know, kind of return some dummy value, return false, right? Now, okay, once we create it, what do we have to do? We have to load in the information. GL uint. Oh no, wait. Return 0. Creating the object. Well, this function returns 0 if an error occurs. GL invalid enum is generated if shader type is not an accepted value. And I think this uint is the actual ID for the shader that it returns, right? So it's going to be like something like 1 or 2. And you have to hold that ID because then you have to use that ID to load in the shader program. So you load in the text and then you tell OpenGL to compile that shader later on. So that's essentially yeah. So yeah, so what we need to do is we actually want to kind of store too much rust. Auto const shader ID. That's what we want to do. And in here we can then do something like Antonio goes, hello my friend. Yeah, Antonio. Antonio's a good friend that joins our stream every day. We got yet another person here that usually watches the stream, so welcome to the stream today. We're doing C++ today, man. No Rust. OpenGL is my nemesis. Who likes OpenGL? Because I certainly don't like writing it. So if the shader ID is 0, that means we didn't create the shader, right? So we don't have an ID. Cool. And then from now on, we have a valid shader ID. And then we have associated shaders. We have shader info, shader source. I think shader source is the one. Returns the source code string, the source code string from a shader object. Okay, so it saves the shader source code. That's not what I want to do. I want to compile the shader. GL compile shaders. There you go. Yeah, once we have the shader object, we can actually put data. Get shader. Okay, finally, look, we have some actual code in the documentation. That's nice. So where do we have create shader in the first place? Yeah, shader source is the one I want. Shader source replaces the source code. Okay. Yeah, you see, we create a shader here, and then we set this shader source, and then we compile the shader. That's exactly what we need to do here. And then there's some errors here as well, like error handling. You can see if the shader was compiled or not. And by the way, we're still trying to install Ubuntu Desktop on my Raspberry Pi so we can see the window. It's been going for a good, I think half an hour now, guys. So yeah, let's call this. So we have the shader, so we can have GL shader source, I think, right? Now we have the shader int, so this is the shader ID. The count, ooh, what is the count? Let's see. What does it say? Shader source count. Specify the number of elements in the string, and length arrays. That does not make me less confused at all. And I gotta love OpenGL documentation for that reason. So what do they do here? Compile. 1. They use 1. Specify the number of elements in the string and length arrays. Oh, okay, so in the string and length arrays. Okay, cool. I got it. What is this? This isn't Rust. You actually have to say how many elements you have in a list. What the fuck is this? So yeah, this is one here. This is the string array. So we simply have a shader data.c string here, right? I think that's what we pass into it. Vertex shader source, fragment shader source, Yeah, I mean, we'll see if this works. We know it works. Yeah, it's a car star star. Okay, yeah, so it is a car star. Const expert C string. Expression must be an L value or function designator. What the fuck? No, it doesn't. No, it does not. And in the length, so let's see what they put on lengths. No, good. At least it compile. It knows exactly how many. Now, what is this? Shader type. Expression must be an L value. Can I do this? Well, the problem I'm having here is that this function takes a pointer to an array of strings in C++. This returns me a pointer to a string, right? So it's a car star. I need a car star star. And I simply cannot do this to get the pointer. For some reason I can't do this because it's not an L value. Now let's see how people are doing it online, because I can't be bothered working out. Shader GLF. I love this example. What is source? Source is a GL car. Okay, it's casting it. It's casting the C string to a const. Okay. I love these casts in C++. I just have no idea what this is doing. It's getting the C string and casting it to a pointer to a GL character. And then taking the source of that. Okay, cool. I kind of got it. So we can do something similar, I guess. Source pointer, and we have a reinterpret cast here of a GL car, I think it was. GL car. Const GL car there. And then we've got shader data dot C string. I really hope this is not undefined behavior, because I have no idea if this is gonna work. And then now we can finally, because this is an L value in C++, we can do this shader pointer. God, how difficult was that? It still doesn't work. It still doesn't fucking work. Typecast. Why does it not work? Why would this not work? Identified shader. Oh, source. Yeah, that's the one. There you go, guys. Times like this, it makes me kind of miss Rust a little bit. Errors. GL generative value generated by OpenGL. So there's no errors that are returned per se in here. But there is an error in the callback if things fail. So we have to basically read the callback if anything happens. So we set the shader source, and then we also we need to compile the shader, right? Compile shader, right? Right? What do you mean? Compile shaders? Come on. Why is this not working now? Yeah, it's GL compile shader. That's what I want. And is that all I need? I think it is, right? yeah, it just takes the ID to the shader you want to compile, and it doesn't return anything. Okay, supported by 3.1. Okay, yeah, it does. Okay, compile shader is not found, but oh well. Now the thing is, after all this time, after all this maybe 20 minutes, we should have some code that takes a shader, a data, so a shader program, a vertex shader, and actually compiles it, right? And returns true if it succeeds and false if it doesn't. So I can just return a true here if everything happens, if everything was fine. Obviously, because this is not Rust, and this is a very old C library, these two functions need some error handling. Needs. Why am I saying this? Well, because they don't, you know, the function that's set in the shader source, if it fails, it doesn't return anything. But it does call on the error callback with a particular error if it fails, right? And it's the same case with the compile shaders. These two functions don't actually return anything useful if it fails, which is a bit shit really, but we can get the errors anyway. So that means we may possibly not return true if they fail. But I'll leave that for a different day. Just a typo there. Now, I wonder if this compiles. But first of all, let's actually get some an example of vertex shader. Show example. Okay, so a shader that draws this. Cool. Attribute vector. Okay, so this is the shader code. So this is GLSL, right? Why am I doing this? Well, because I just want to test this thing. Let's put it in the header. We can have our test. I guess our const expert string view, I guess. Can I have this? Can I have a const expert string view? Because I'm gonna ask my shader to be this shader to be compiled, right? And I'm not sure if it's gonna compile because this is WebGL. Is GLSL the same thing for WebGL as well? I hope it is. Okay, cool. I mean, this should be a compilable thing. But yeah, let's include this on our main executable and see if it works really. So private visualizer, we have a GL abstractions, which means that in the main C++ we can include the code that we just wrote. Let's include them here. And I want to kind of do this here, right? So I want to do compile shaders, please. Compile shader, there you go. What did I call it? The test, the shader code. Streaming yourself coding wild. Big man Ben. Hey Big man Ben. Welcome to the stream. Although it's perhaps nearly the end now. Yeah dude, it's crazy. Streaming myself coding. Not many people do it, right? No sarcasm by the way. Guess I just like having people watching me while I make loads of mistakes. Best thing ever. this toString does not work. I just actually have to turn this into a string, I guess. It's the string. I like it. We learn with you. Yeah, indeed. Thank you. Yeah, that's basically why I do it, so I can learn code a little bit faster, because there's multiple people telling me what I've done wrong. And it's much better than coding on my own. So right, so we need shade code, shade string. Okay, this should build, right? Warning, control reaches the end of non-void function. Okay, we can solve that. We can solve that. I mean, it's virtually impossible for us to reach this, but I guess C++ isn't smart enough to figure it out. Anyway, update on like an hour later, we're still installing things. There you go, not so boring. You think companies can hire someone like me who only codes with the help of GPT? You mentioned a previous job somewhere. Look, like, I don't think if you just mention that, you'll get hired, by the way. If you just say that you can only code with GPT, you know, they'll probably not hire that. However, you can use that to your advantage. So like, you can just start some personal projects and then actually learn to code by yourself, maybe with the help of GPT, maybe with the help of just watching videos or reading online. And once you've done that for maybe, let's say 6 months, that's a reasonable amount of time for you to learn a language, I guess. Then you can go for interviews and you can really start to get the feel of it and you can pass those interviews. But yeah, I mean, I can't say that if I'm interviewing someone and they say they only code in GPT, you know, that's not the kind of like skill I'm looking for. I'm looking for someone who can actually just solve problems on their own, and not necessarily like knowing how to code very, very well. If they're just good at solving problems and then they need the help of Google to solve something, that's fine, you know. But yeah, just bear that in mind. Just use GPT to your advantage to actually learn it. That's what I would recommend. And look, every programmer, no matter how good they are, none of them know everything, right? I'm not a very good programmer, as you can probably tell, but I do have a lot of experience, and even I have to Google things all the time. I have to go on GPT all the time, just to search for basic things sometimes, you know. I think at the start of the video I was looking at how to create like a custom unique pointer in C++, which is something very basic, but I just forgot, you know. You're never gonna know everything. Thank you. I'll see what I can do in that direction. Yeah, just make sure you keep learning, dude, and then you can basically solve some interview problems before you actually start applying for interviews. And you can find them online very easily if you just look for language interview questions, like Python interview questions. You get many of them. Just practice them and make sure you can do them by yourself, and make sure you can explain your solution quite well, because that's what the interviewers would be looking for, someone who can like work well in a team and explain their solutions. That's what I look for if I have to interview someone. So yeah. Oh, we finally finished this. Yeah, so just in time, because we actually potentially build the program that can compile the shaders, so compile the OpenGL shaders. And with that in mind, we can also try to remote connect to my Raspberry Pi to be able to see the window that we created in the previous compilation, because we did create a window. So that's what we're gonna have to, I guess, do here. Okay, so let's install this real quick. So what I'm gonna install here is just a server for remote desktop connections. Yeah, but Antonio, as I said yesterday, in C++, dude, the code compiled, but is it gonna work? Absolutely fucking not. And you're about to see that. Something is not gonna work, I guarantee you. That's one of the things in C++. So systemctl enable, oh gosh, I just clicked on someone's advert. Someone got some money for that. Yeah, if everyone who's watching can subscribe, I would highly appreciate, guys. I'm trying to basically reach the goal of 1,000 by the end of the year, and we'll see that. I also need to create some new videos, man. I've not created a new video, actual like explanation video in a while. I think it's been over a month now. So yeah. Okay, so now we can do, what is it, Windows, remote desktop, computer. Wait, what? Computer, okay, so I think this is the one. Yeah. Session XOR. Yeah, hey, this is the Raspberry Pi. Does it work though? Am I doing anything here? Like, how do I know it worked? Okay, it's just initializing, I guess. So that's cool. That's cool. That's cool. It's kind of buggy, this. I mean, I'm gonna let it initialize. Bear in mind, this is a Raspberry Pi 4, so it's gonna be fairly slow, guys. Fairly slow. But you know, if I go on my terminal here, and this is a terrible terminal. What the hell is this? There you go. Z shell is up. So if I go on my development, I think I called the audio visualizer, right? And if I go to my build directory, Unix build. Sorry, Ubuntu has experienced an internal error. Okay, send it. I don't care. Fucking hell. The connection is so slow, you have no idea. Like, I'm not sure if it looks good for you guys, but I'm typing and it takes like a second for it to show up. Yeah, there you go. So let's just open the visualizer and see if it creates a window. Failed to set a callback. Cool. Failed to initialize glue. Cool. Why? So it failed to set a callback and it failed to initialize glue. Now, why might that happen? And that's what we're going to see now. So it failed to initialize, failed to set a callback. Why? Previously set callback or no. If this is no, could it be maybe the logic here? Although no is 0 and 0 is false. So yeah, that logic should be fine. But anyway, I mean, we're continuing anyway, it doesn't matter. So we create the window, failed to start window. Did it fail to start a window? No, it failed to initialize glue though. If glue init. And why might it fail to initialize? I think there is an ordering to these things. I think I basically have to initialize it up here. Is it? I think it might be this. I think it might be because I have to initialize glue. Shit, since remind me later. I don't care about it now. Yeah, so let's build it and see what happens. I'm pretty sure this error here only occurred because it didn't really initialize the OpenGL, but we'll see. There is an ordering to things, I'm pretty sure. GLFW init and glue init. Do I need to call glue init for every GLFW window? I want to see this guy's thing. Loading OpenGL functions is an important task for OpenGL. We are strongly advised to use OpenGL loading library instead of manual process. However, if you want to know how it works, if you take a look at that, in other words, calling glue init multiple times with no other side effect other than explained in the OpenGL wiki. There you go, something happened there. Address sanitizer, I want to know what address the signal is called. Oh yeah, apparently I'm running address sanitizer, so that's automatically going to fail this. What's the issue here? Lib start call main. I think this is line 56 is what's causing me a compile shader is causing me a little address sanitizer issue. And what is it? It's probably because I leaked something in here. I have no idea why. Does it tell me what it is? So hint, address points to the 0 page signal. PC points to the 0 page. Let's see what error that is. Like no pointer maybe? PC points to 0 page. C++. Yeah, this is just address sanitizer. You know, for the sake of this of this stream, I might actually disable address sanitizer. So what am I on now? I'm on Unix make debug. Unix make debug. Unix make debug. There you go, sanitize address. Very bad, don't do this kids, because address sanitizing is good, but I know that there's an issue somewhere that I don't want to fix now. So yeah. Yo, did I miss something? Shit, I just got free from my work. I always wanted to make all the visualize. Yeah, dude. So maybe this week you can tune in. Unfortunately, we're at the end of the stream now, but you joined, you know, I guess not a bad time where I'm actually seeing if my program compiled and it works, and if it works, sorry. But yeah, man, the plan is to also make a C++ audio visualizer alongside the web crawler when I get bored of it, so I can switch between the projects with OpenGL. And right now I'm just trying to create a window. So yeah, and let's see on the Raspberry Pi what it looks like. Okay, no, there is definitely an issue. And there is a segmentation fault. And because of my shaders code, because of this thing here, this is the issue, line 59, which comes in here. Are you using any external library for audio encoding, decoding? Not yet, I haven't got to that part yet, but I will certainly have to use an external library. If you've ever looked into reading audio files, even wave files, that it's very difficult. It's not that easy. So I'm not going to write that by myself, I guess. And then when it comes to MP3 and all the other types, OGG, they become even more difficult. So yeah, I'm not going to be writing that myself. So address points to 0 page. So we have a null address. Signal is caused by read memory access. It's this thing here. So shader data .c string. I'll reinterpret the cast to Does that work? If I remove the reinterpret cast. No, it still doesn't work. Guys, I'll have to fix this issue later because I don't really have time to do that now. But I want to see if the window works nonetheless. So I'm just going to basically comment these 2 lines here. Yeah, that's what I was wondering, if you're willing to lose your sanity and write encoder from scratch. Yeah, dude, I'm not willing to do that. I've tried before though. I've tried to read WAV files and it's very difficult, I must say. But yeah, I mean, maybe we'll do the Fourier transform by ourselves. That's not too as difficult as it is decoding audio, and it is very mathematically heavy, I guess. The GLFW is not initialized. The GLFW library is not initialized. Huh? Like, why? Why is it not? Why is it not? Create window. Make current. Pretty sure I have to do that. I remember I used an audio library for playing audio. Oh, nice. An audio. I would check that out. I've not heard of that one for C++ though. In C++, I guess you can use like port audio, which is what I've used before, but that's very low level. Very, very low level. There must be something better than that. So as of now, you just render an OpenGL window. Yeah, basically, that's what I'm trying to get, but there is something wrong here. Failed to initialize glue. Like, why? If glue in it. What does glue in it return? So glue in it. Let's take a look. Returns glue OK. Oh mate, if glue OK is defined to 0, I'm gonna die. Because that means it is passing, it's just returning nothing. Oh, fucking hell, that's why. Yeah, I mean, you gotta love the way you have different meanings for OK in C++. Let's try again. Let's try again. The GLFW library is not initialized. The GLFW library is not initialized. Yeah, it is not. Is it because I have to initialize it? Could that be it? GLFW terminate. Huh? So fail to set callback. But it is initializing. GLFW. The GLFW library is not initialized. Even though I have initialized it. Oh. Do not use construct, destruct, initialize, destroy OpenGL object. Instead, use a member functions. Create a class that owns OpenGL related objects. This class should also be responsible for creating context and destructor. That's not my issue. Did you set display environment variable aside from installing OpenGL? I need to configure X. Okay, right. Set display 0, 0. Okay, let's try that. No, that doesn't even work. Have you worked with graphics API before? I tried looking into OpenGL a few years before, but too much complicated for me, as I was a beginner at the time. Yeah, believe it or not, I actually worked with OpenGL for 2 years after I finished my studies. So, but as you can tell, I've forgotten everything. So. Yeah, I feel like this is something to do with my Raspberry Pi not figuring out that it has a display now. So it is something to do with my code actually. And unfortunately we're not going to achieve this today because it's getting late now and I'm going to have to call it a stream, guys. But I mean, looking back, what we did do is we set up all the CMake project here that has the audio visualizer exe, right? So the executable, and also a library where I want to kind of put all my OpenGL abstractions, as well as pulling all the dependencies of Conan. So we pull OpenGL, FMT, and GLFW all through Conan. So kind of similar to what Cargo does, I guess. And we do compile it, but it just doesn't work. And then I'll try to figure out why it doesn't work before the next stream, but we'll see. Antonio, Donna J, wow man, you should create your own game engine now because your whole game engine controversy, if you're aware of. Yeah, I've read it in the news. They're gonna start charging more, right? Unity, that is, I guess. I mean, I'm not sure if Unreal is doing anything. But yeah, I mean, Unreal I think is still the same, but yeah, people are mad with Unity. Not So Boring, thank you for the stream. See you next time. Thank you, Not So Boring. Thank you very much for joining and subscribing. And we'll look forward to seeing you soon in the next streams. And Antonio, good night. Boa noite, amigo. Yeah, see you guys. See you maybe tomorrow. Yeah, if I stream tomorrow, I'll see you again, Dana J. But yeah, have a nice work tomorrow. Have a good evening. Everyone get a good night of sleep, and I'll see you guys. Bye bye.